The Hertzsprung-Russell Diagram. It was in the early 1900s that Hertzsprung and Russell independently plotted data about the luminosity and surface temperature of stars onto a diagram, something like this. Here on the y-axis we have the relative luminosity, the Sun being the reference point with a luminosity of 1. On the x-axis we have the surface temperature in Kelvin. Now this is quite unusual in that the temperature actually increases in this direction, and you'll see that equal distances on the graph equate to a doubling of temperature. This is not a linear graph. So we go from 2,500 to 5,000, double to 10,000, double to 20,000, and so on. The y-axis does get more luminous going up in the conventional sense, but again it's going up in increments of a factor of 100. So going from here to here we've increased luminosity 100-fold, another 100-fold increase, and so on. We can add to this the spectral class of the stars, O for the hottest stars, B, A, F, G, K, and M for the coolest stars. The Sun, being a G star, obviously with the same luminosity as the Sun, appears about here. When Hertzsprung and Russell plotted the data for the known stars, they found that the stars didn't lie randomly around the chart, but the vast majority, over 80%, would lie somewhere along this line, which they called the main sequence stars. As stars get hotter, coming in this direction, you'd expect them in general to become more luminous as they go up. A significant number of stars appeared in this region, and although cool and having a red colour as M-class stars, were rather more luminous than the main sequence stars, and therefore must be much larger. These became known as the red giants. Red because they're cool and so have a red colour, giants because due to their luminosity they must be large stars. There are a group of stars in this region here, which had a wide range of temperatures, but were all extremely luminous, and so must be extremely large. They became known as the supergiants. And down here, some stars with a very high temperature, but not a huge luminosity. They became known as the White Dwarfs, the high temperature giving them a white colour, but their low luminosity meaning they must be small stars. Now to summarise some of the facts about these four types of star. The main sequence stars. Well, this is over 80% of the stars we see in the sky, and they gain their energy from nuclear fusion of light elements, mainly hydrogen. The Sun is a main sequence star and is gaining its power from fusing hydrogen into helium. The red giants are cool stars, giving them the red colour, and so have a low intensity or power per square metre. Each square metre of a red giant gives out a relatively low amount of energy per second. But they have a very high luminosity due to their large size. The supergiants. Well, these are very large stars and so have an extremely high luminosity. They can be hundreds of times larger than our Sun. And the white dwarfs. Well, these are high temperature stars, giving them the white colour, but have a low luminosity as they are small.